Hello friends, welcome to GSR ChemTube channel. In this video, we are going to discuss about chemical bonding chapter from this about coordinate covalent bond. The coordinate covalent bond is also known as dative bond. In general, a covalent bond is formed by two atoms sharing a pair of electrons. The atoms are held together because of the electron pair is attracted by both the nuclei of these atoms. In the formation of a simple covalent bond, each atom supplies one electron to the bond formation. But in some special type of covalent bonds, the shared pair of electrons are contributed by one of the two atoms only. Such type of covalent bonds are called coordinate covalent bonds or dative bonds. So, in general covalent bonds, both the atoms contribute one electron for bond formation, and these two electrons are shared by both the atoms after the bond formation. But in some special cases, both the electron are donated by one atom and these are shared by both the atoms, and hence a covalent bond is formed. Such kind of covalent bonds are known as coordinate covalent or dative bonds. So definitionally, the covalent bond in which both the electrons of the shared pair are contributed by one of the two atoms and are shared by both the atoms is called a coordinate covalent bond. As we said already, these bonds are also known as dative bonds. A coordinate or dative bond is established between two such atoms, one of which has a complete octet and possesses at least a lone pair of electrons, while the other is short of a pair of electrons to get octet. So representing of these coordinate covalent bonds is in simple diagrams, a coordinate covalent bond is shown by an arrow. The arrow points from the atom which is donating the pair of electrons and to the atom which is accepting them. Let us see for an example for the molecule having a coordinate covalent bond, that is ammonium boron trifluoride, or simply to say the reaction between ammonia and boron trifluoride. Although the nitrogen atom has completed its octet in ammonia, it still has a lone pair of electrons in its valence shell, which can be donated to others. In the other way, the boron atom in the boron trifluoride is short of two electrons, which accepts and completes its octet. When these two molecules approach each other, nitrogen can donate this pair of electrons to boron, and hence a coordinate covalent bond is formed between these two. So this same molecule can be represented by using line structures also in this way. So ammonia molecule can be represented like this, which is having a lone pair of electrons on its central atom nitrogen, whereas boron trifluoride has boron as central atom which has deficiency of two electrons still. When these two molecules combine, they can form a coordinate covalent bond between nitrogen and boron, and hence ammonium boron trifluoride molecule is formed. Any atom or ion or molecule which has one unshared pair of electrons which it can donate is termed as Lewis base, while those which are capable of accepting these lone pairs are termed as Lewis acids. In the earlier molecule ammonium boron trifluoride, ammonium is donating a pair of electrons, hence it is termed as Lewis base, whereas boron trifluoride is accepting that pair of electrons, hence it is Lewis acid. Now let us see one more example, ammonium ion formation. Hydrogen ion has no electrons and thus accepts a lone pair of electrons donated by nitrogen in the ammonia molecule, and hence a coordinate covalent bond is formed between these two to form ammonium ion. We have to note one point here. A coordinate covalent bond is, after formation, completely indistinguishable from a covalent bond. That means, before the bond formation, there is a difference between covalent bond as well as coordinate covalent bond. But once after the formation, all the bonds seems like same. Let us see one more example here, that is the formation of ozone molecule. In the ozone molecule, there are three oxygen atoms. Out of these three, two oxygen atoms are linked by a double bond. That means sharing of two pairs of electrons between the two oxygen atoms. After formation of this double bond, each oxygen atom has two lone pairs of electrons in their valence shells. When one more third oxygen approaches this, one lone pair of electrons and one of the two oxygen atoms donated by those to this third oxygen, and hence a coordinate covalent bond is formed between them. Hence ozone molecule is formed. Some of the other molecules having coordinate covalent bond or dative bond are like carbon monoxide, sulfur dioxide, sulfur trioxide, ammonium chloride, nitric acid, etc. These all contain coordinate covalent bonds in them. Now let us see the characteristics of these coordinate covalent compounds. Generally, the properties of coordinate covalent compounds are intermediate between the properties of ionic compounds as well as covalent compounds. Coordinate compounds exist as gases, liquids, and even as solids under normal conditions. The melting and boiling points of these coordinate compounds are higher than those of covalent and lower than those of ionic substances. These coordinate covalent compounds are less soluble in polar solvents like water, but readily soluble in non-polar solvents like benzene, carbon tetrachloride, etc. Like covalent compounds, these coordinate covalent compounds also poor conductors of electricity. They undergo molecular reactions which are slow. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates.